Hey guys, and welcome back. So far, what we have done in our environment here is we have spun up a single master node in a Kubernetes cluster. So we have a brand new cluster here. It's just a single node working by itself. And we need to add in a second node, but before we do that, we actually need to install a container network interface into our cluster. And if we take a look at the documentation for Kubernetes right over here, you can see we've got the initialization of the first control plane node that will go ahead and create a new cluster. And of course, one of the things that we need to do is to apply a CNI or Container Network Interface plugin of your choice. Now, one of the ones that I've found that works pretty well for me is the Calico CNI. So let's go ahead and just search for the Calico CNI documentation, and then we'll find the documentation to install Calico for Kubernetes. And I'm going to choose self-managed on-prem, and we'll just drill into the documentation here, and we'll go ahead and download the necessary manifest file onto our local file system. So just hit the copy button, and we'll come back over to our terminal here and run that to download the file. And then, of course, you could cat that file if you want to, but it's pretty large. It just creates a bunch of different resources to create the Calico CNI. And then we'll go ahead and run a kubectl apply on that YAML file. So let's go ahead and paste that in, and that will install the Calico CNI onto our API server here. So now if we do a kubectl get all on the namespace kube-system here, we should be able to see that Calico is installed. And sure enough, you can see we've got a daemon set here, and that's still in the process of getting spun up. You can see we also have a deployment here. And also, because we didn't have a CNI installed yet, you'll also see that core DNS was actually not up and running either. So it actually created a couple of pods, but they're just in the pending state. So if we run that command again, after just a minute here, you can see that core DNS is now successfully running. The deployment controller for core DNS is happy. It has 2 out of 2 pods running. And the deployment controller for the Calico CNI plugin is also happy because we have Calico up and running right up here. So once we've got that CNI installed, we can go ahead and add an additional node into our cluster. And we've already got the load balancer set up. So our target group is actually technically configured to forward traffic to CBT master 02 in addition to CBT master 01. However, at the moment, CBT master 02 is showing as unhealthy because the API server for Kubernetes is not currently running on that node. So what we need to do is go ahead and grab the command from our first node. So let me actually scroll way up here, and we're going to find the output from when we initialized the cluster. Let's scroll past our Calico YAML configuration file here and see if we have it in the history. And it looks like we've got it right here. And so what we're going to do is basically copy this command right here in order to join an additional node into the cluster. Now you'll notice that we have a couple of different join commands. So there's the one that I have highlighted right here, and it says you can join any number of control plane nodes using the following command. However, down here, you can see that we have a separate command in order to join worker nodes into the cluster. So if all your objective is to add worker nodes into your cluster, then you can use this command right down here in order to join the node as a worker rather than a control plane node. Now, in order to join a control plane node, there's actually a couple of additional parameters that you need. You can see that we've got the discovery token CA cert hash. That's actually consistent between both of them here. But what we also have that's a little bit different is the certificate key right here. And this is basically a pointer into a config map that was created as part of the initialization of the cluster to help the new node locate the necessary certificates on the first node so that it can configure itself. And this is kind of a shortcut to manually copying certificate files around to the different nodes. And so if you have enabled the upload certs option, which we actually saw in the documentation, we didn't really cover that specifically, but when we spun up our node here, when we ran kubeadm init, you can see that we've got our control plane endpoint parameter here that points to our load balancer. But then on the far right here, we've also got the upload certs. And so that's going to upload the certs into the cluster as a config map so that when we deploy a new node, it is able to pull those certificates directly out of the config map rather than us having to manually copy those certificates from the first node into the second node. And we can actually verify that by going into node number 1 here. And if we do a kubectl get all on the namespace kube system here, we should have, whoops, let me fix that command. That's kubectl. And we should have a config map here. Let me actually do a get on the config map resource type. And you should see that we have kube root ca cert right here. So let's go ahead and do a kubectl get config map, and then we'll paste in the name kube root ca cert. And if we do a describe on that to get a little bit more detail here, you can see that we've got the CA certificate for our Kubernetes cluster. And so that's one of the resources that will be retrieved by the new node when we run the kubeadm command. We also have the kubeadm config map here as well. And so let's go ahead and explore that one and see what's in there. And you can see that we've actually got a configuration file in here as well to help configure your Kubernetes cluster. And that can automatically be discovered by the other node by referring back to that config map. So let's go ahead and copy this command to our clipboard so we can run it. That's going to be right up here. And we'll copy this kubeadm join command to our clipboard. And then I'm going to switch over to node number 2 on the right-hand side here. Let me get SSH'd back into it because it looks like I lost my connection there. And I'm going to go ahead and do sudo and then just paste this command in, and we'll run that command. So essentially what this command is going to do is it is going to join this node into our cluster, and it's going to use this load balancer endpoint as the endpoint to connect to the Kubernetes cluster using utilities like kubectl. Now, eventually, after this utility, after the kubeadm command has succeeded, the node will have the API server component up and running on it on port 6443. And so our load balancer is actually going to eventually detect that this node is in a healthy state, and it will begin routing traffic into it. Awesome. So it looks like this node has successfully joined our cluster right here, as you can see. And we are going to go ahead and run these commands to copy the kubeconfig from the etc kubernetes/admin.conf file into our home directory here as well. So let me go ahead and just copy that and paste it in here. And we should be able to run kubectl version. And of course, you can see that under server version here, we are getting a successful response, and that is indicating that we are able to successfully connect to our cluster. So at this point, if we were to run, kubectl from either node 1 or node 2, it doesn't really matter which one we use because both of them are communicating as part of the same cluster. So one of the commands we can use in kubectl is to do kubectl get nodes. And as you can see, if we run kubectl get nodes, we get 2 nodes returned to us on the CBT master 01. And then if we were to run that same exact command over here on the second node, you'll see that we get the exact same result here. So both of these nodes have now been joined to our cluster, and they both are acting as control plane and master nodes. So we can manage our Kubernetes cluster from either of these nodes thanks to the load balancer. So if we were to switch over to the AWS Management Console here, you can see that our secondary node, CBT Master 02, has actually changed over to healthy thanks to the health check configuration that we have, which is basically just verifying that it can communicate on TCP port 6443 to the nodes that have been registered with this target group here. So at this point, we've got a multi-node cluster with more than one node as acting as a master node in our Kubernetes cluster, and we can now start to either join worker nodes to the cluster, or we could start to deploy workload resources such as pods or deployments or replica sets or whatever else you'd like to. I hope this has been informative for you, and I'd like to thank you for viewing.